What is today's date? 7, 10. We are doing general property. I will, you have to write notes properly, but I will do more in the form of the questions rather than just theory. You know, most of these things are given in the theory form, which is very boring. That's why I will do main topic, but along with that, I will ask question and I will frame question for everything. The first property is atomic radii. Sania, am I audible?
Yes, sir.
Sarah, can you hear me?
Good evening, sir. Yes, I
Good
can.
evening. Okay. So we are doing general property of transition element, and first topic is atomic radii. When we consider atomic radii, then it will lie between the S block and P block. S and P block, which is logical. It means it will be smaller than S and bigger than P because uh, what happened along the period Samarth in atomic radii?
It should decrease, sir.
Size decrease.
Yeah.
If size decrease, it means D block is smaller than F and bigger than P. Correct? Example, if you have S block, D block, and then P, then it is the biggest in size, and this one will be the smallest in size. And in same way, you can compare two important factor that decide what will be the size is Sania. What are the two major factors that decide atomic radii? Nuclear charge and shielding effect. Very important. Nuclear charge and shielding effect. So, Pratigya, what is the role of nuclear charge and shielding effect? Nuclear charge decrease the size and shielding effect increase the size. Answer fast or say, I'm not sure. Okay, every single person. So, nuclear charge, because if there is more nuclear charge, it means nucleus is attracting the electron, size will reduce. Shielding effect, it means less impact of nucleus on the electron. And when there is less impact, it means there will be increase in the size. Correct. So we see the effective nuclear charge. What is the impact of the effective nuclear charge? Now, when we come to specifically D block element, example 3D series, here you have atomic radius, and this is given in NCERT as well. And here you have any group, example 3D series, 4D series, in a specific thing. And when I'm saying group, it means example, let's take 3D series. Okay. So in this 3D series, what happened from scandium to manganese, you will see size is drastically reducing. Then if you see manganese to the copper, it is more or less remains same. And then it will slightly increase in case of zinc. So this is abnormal trend. From scandium to manganese, it is sharply decreasing. Manganese to nickel or copper, it is almost same. And in case of zinc, it is decreasing. And question will be asked, what is the reason? Sarah, what could be the reason in the beginning? There is a sharp decrease in the atomic radii.
Not sure.
So atomic radii is sharply decreasing. One thing is whenever size decrease, main reason is the nuclear charge. If size increase means nuclear charge is more. If size is increasing, shielding effect is more. So if you are not sure, just always, not only in this chapter, in any chapter, always apply this logic. Mo- Most of time it will be correct. If size is decreasing, nuclear charge is more. If size is increasing, shielding effect is more. Now tell me, Sarah, if in the beginning nuclear charge decrease sharply, what could be the reason?
The nuclear charge
Nuclear
increases, the
charge.
size decreases.
Exactly. So what happen? We have less d orbital electron in the beginning, and when you have less number of d orbital electron, there is not much shielding. Like in the beginning, if you have less people, they cannot shield properly. So that's why you will see, I will write in the short form, shielding effect Se and nuclear charge Nc. Okay, so we'll use these two terms, nuclear charge and shielding effect. So what happened in this case? Shielding effect is weak or poor. Reason? Because there are not many people to shield the electron. And if shielding effect is poor, what will happen? Nuclear charge impact will be more. Effective nuclear charge, and both will conclude you effective nuclear charge. Both will conclude you effective nuclear charge. Nuclear charge ENC. So in this case, if you know even nuclear charge is normal and shielding effect is weak, you know effective nuclear charge will be more, and it is responsible for decrease in size. Anybody have doubt in this? Tanya, in the middle, atomic radius decrease slowly. What is the reason?
Sir, because of the stable configuration.
Same shielding effect and if this nuclear charge. In this case, there will be counter effect of nuclear charge as well as shielding effect. It means both will counter each other. Counter effect of nuclear charge and shielding effect. If both are almost same, then there is not much difference in the size. Understood? Why it is same? Because now there are more number of people, more number of electron to shield. Example, in case of manganese, in d orbital itself, you have 5 electron. These 5 electron will shield further electron. Okay. And third part, if you see in the end, atomic radii is increasing. Barinder, what is the reason?
What, sir?
In the end, atomic radii increase. What is the reason?
Shielding effect is more, electron is
Shield.
more.
Exactly. So in this case, shielding effect is more. Why? Because of the more electron in d subshell, and when there are a lot of electron in subshell, so it will overcrowd, and overcrowd become good uh, shield, and that's why it reduce the impact and of the nucleus. If impact of the nucleus is less, it means effective nuclear charge will be less. Effective nuclear charge less means size will increase. And what is the reason? Full filled subshell. In case of zinc, it is 3D10 4s2. D subshell is full, S subshell is full. Everything is full. Understood? Anybody have doubt?
No, sir.
Next, Samarth. Size of 4D series and 5D series is almost same. What is the reason?
The lanthanoid contraction.
Yes. Size of 4D series and 5D series is almost same. And reason is lanthanoid contraction because question will be framed in the same way. That's why today we are doing in the form of the question rather than theory. Next, Pratigya. Oxidation, as oxidation state increase, atomic radius is decreasing. Why?
Nuclear size decreases.
As
Nuclear
oxi-
charge. More nuclear charge.
more nuclear charge. Why?
I'm not sure, sir.
Sorry, sir, I got
Bec-
late.
is okay, Anvita. So when oxidation number increase, example, if you say manganese 7 positive or chromium 6 positive, ionic radius will be less. Reason is your periodic classification. We did yesterday. Ki if there is more positive charge, what will happen? Cation size is small compared to the original. And when cation size is small, what will happen? Overall radius will decrease. Makes sense? And that's what we are saying. Ki more charge, donation of electron, strong attraction, proton is same, but electron reduced. And if this happen, what will happen? Effective nuclear charge will be more, and in this case, size will reduce. Any doubt, guys?
No,
If you see logically, D block size, and we already said D block element size is smaller than S, bigger than P block. Why, Anvita?
so could you repeat the question?
D block element size is smaller than S block and bigger than P block. Why?
I don't know, sir. Does it have something to do with lanthanoid contraction?
Reason is same. Along the period, size normally decrease. So ionic radius of, and by the way, whenever I am writing in this blue color, basically this is question. Ionic radius of the transition element is small than representative element. Samarth, what is the reason? This is very important. I would mark this as 10 star because I'm sure you haven't read about this. None of you. If anybody is damn sure, let me know. Ionic radius in the transition element is smaller than the representative element, and both representative element. Anybody?
Yes.
Yes, Samarth.
Is it property of d orbitals, sir? Like they are more
What is the
outside from.
orbital? What is the property?
So like the shape of d orbital, they are away from the nucleus as much as possible compared to
Hmm.
p. So any electron in d will be away.
No. Answer is we definitely know that D block will be smaller than the S block element. Correct? If you consider D block element, then along the period size decrease. So always smaller than S block element. So there is no doubt about this. But problem is why it is bigger than P block? Because it should be bigger. Sorry, it is smaller than P block because logically it should be bigger than P block. So what makes sense? Why? That's what I was asking.
Not sure here, sir. Like, I think.
Anybody who is damn sure about this answer?
I
Because
am not
P,
sure, sir.
yes, anybody? Because P block element are formed by anion, but D block element are formed by cation. Or you can say P block element form anion, and you know anion is bigger, but D block element form cation. And you know general rule, anion are way bigger than the cation. Make sense? Example, if you take sulfur, then sulfur is formed by two negative ion. But if you take iron, iron is formed by the two positive, or zinc, two positive. Make sense? You know, cation size is smaller than the anion size. Any doubt, guys?
No doubts.
Hmm. Second, size is done, atomic radii. Second, सात क्या बन? Just give me a minute. Yes, guys. So this atomic radii and ionic radii is done, and ionic radii is more important because you know there are more questions. Just give me a minute. ठीक है. Okay. So second is the metallic character. Anvita, why transition element are metal? I will write question in the form of question. Why transition element are metal?
Um,
Huh.
something to do with ionization energy, right?
Yes. Ionization enthalpy is low and metal have low ionization enthalpy. So what happen if there is low ionization enthalpy? Lose electron easily. Okay, okay. And when they can lose electron easily, then there will be metallic bond form because metallic bond formed by the losing electron. So that's why they are metal. So what is the property of the metal? Low ionization enthalpy, loss of electron, and formation of the metallic bond. Okay. Next, Tanya. Why transition element have high melting point and boiling point?
So because of their bonding,
Which bonding? Which bonding? Or same question can be asked in different form ki why they have high enthalpy of atomization. And we discuss in one of the class high enthalpy of atomization. Answer is same. And we discuss this because of the unpaired electron in the d orbital. So when you have unpaired electron in d orbital, what will happen? Metallic bond will strong, and when you have more unpaired electron, there will be stronger metallic bond. Same thing we discussed in the last point. In low ionization enthalpy, lose electron easily and form metallic bond. More unpaired electron, they can lose electron, and that's why strong metallic bond. And if metallic bond is strong, then there will be high melting point and boiling point. Got it? Barinder, why zinc, cadmium, and mercury are soft? Why?
Paired electron.
Yes. Why zinc, cadmium, mercury are soft? Reason is same. We said ki more number of unpaired electron means more metallic bond, strong metallic bond, high atomization enthalpy, high melting point, boiling point. Here we have full-filled d orbital, and when there is no unpaired electron or very less unpaired electron, what will happen? Metallic bond will be weak and they are soft. So no unpaired electron. If there is no unpaired electron, in this case, there will be weak metallic bond or no metallic bond. And if there is a weak metallic bond, they will be soft. Sarah, why chromium, molybdenum, and tungsten are hard? Why chromium, molybdenum, and tungsten are hard?
Strong metallic bonding.
And what is the reason of strong metallic bonding?
The unpaired electrons.
Maximum number of unpaired electrons. Maximum number Oh,
Sir, we'll go for the attendance and come.
okay. Electron, so strong metallic bond. Just give me a minute. Strong metallic bond. Guys, am I audible?
Yes, sir.
So maximum number of unpaired electron. So strong metallic bond. Okay. So when we talk about the melting point, boiling point, and if you see graph, then graph will be weird. Example, if you see melting point and any specific group, Samarth, what should be the graph shape? Straight line, parabola, hyperbola. What should be the shape?
Just parabola facing down.
Parabola facing down. Answer is we know as an unpaired electron keep on increasing, it will increase. So straight line graph like this. But suddenly there will be dip. Example in case of manganese, then it will increase and then it will keep on reducing. M. Okay, and this graph is given in NCRT again. Key question will be asked why there is a dip in case of manganese. Chandana.
Sir,
Yes, Pratigya.
the Sanya is not feeling well, so he is left in the class.
Okay,
Sir, because of more unpaired.
because of more but it should be maximum in case of unpaired electron. See, if you see melting point trend, question fifth, melting point trend, then it, you know, in the beginning unpaired electron will increase. In beginning unpaired electron increase, so melting point increase, and after that, like, and in the end you will see unpaired electron will decrease, keep on decreasing from the iron to zinc, so their melting point will decrease. So it makes sense. Initially it increase, then decrease. But my question is, why there is a dip in case of manganese?
Sir, maximum oxidations.
But maximum oxidation state means maximum unpaired electron. So it should be more.
I'm not sure.
And same thing happen in the technetium also, TC. Example, if this is for 3D series, if you try to make for 4D series, I'll change the color. Yeah. So it will be more or less like same. This, then it will dip, then same almost I'm like. So this is 3D series. This one 4D series. And same way you can have 5D series. But interesting fact is in this case there is no dip in case of 5D series. In 3D and 4D series there is a dip in the middle, but in 5D series there is no dip. And example here you have tungsten. Tungsten have one of the highest melting point in the nature, one of the highest. Okay, so if it start with the hafnium and with the like ending part just before the ending gold, and in the mercury are not proper even solid, you know that, right? Then here it start from the yttrium and it goes up to the this Ag, silver and copernicium. Here it is from the scandium to go to up to the copper. Because in case of zinc, mercury, and this copernicium, you don't have unpaired electron. So it's extremely low. Correct. Point is why there is a dip in case of manganese, or same thing you can apply in the technetium. This will be technetium, TC. So answer is, example, if you take in case of manganese, so manganese electronic configuration will be organ 18, 3d5, 4s2. It is stable configuration. And why it is the stable configuration? Because of the half filled electron. Because of the half filled electron. And when you have stable configuration, what will happen? It will be tightly packed and delocalization will be less. If stable, tightly packed, less delocalization of electron, less delocalization movement of electron. If less delocalization of electron, then you will see there will be weak metallic bond. And if you have weak metallic bond, what will happen? Weak metallic bond means less melting point and boiling point. Make sense, guys?
Yes, sir.
Huh. Next, Samarth, why 4D series and 5D series have more melting point compared to 3D series? Six, seven. Why 4D series and 5D series have more melting point than 3D series?
Is it because of mass?
Because of the mass.
Yeah, and
Because
since they're similarly packed, so volume must be same.
no, but packaging more or less is same in the same group. Size. Size in case of 4D and 5D is more. And whenever there is bigger size, electron removal become easy. And if you can easily remove electron, you can form strong metallic bond. And if there is a strong metallic bond, melting point, boiling point will be high. Understood, guys? Any doubt? Mm, Next, two topic are done. Third, density. Sarah, what will happen to density? What is your sequence? Let me check. Anvita, Pratigya, Barinder, Chandana, Samarth, Sarah. Huh. What is what happen? Like, what are the changes happen in the case of density in D block element? Because we know density is equal to mass by volume. There is not much change in the mass, but as you know, volume is decreasing. What will be the impact on the density, Sarah?
It will increase, sir.
Yes, so atomic size decrease a long period, and when metallic size decrease, then atomic volume will also decrease, and if atomic volume decrease, then density will increase. Then density increase. Why? Because volume decrease. What is the reason for volume? Decrease in the size. Okay. So that's why you will see if you take from this scandium to zinc, then our density will increase continuously. Next, one of the most important topic is ionization enthalpy. Very popular in this chapter, ionization enthalpy. And they ask a lot of questions from the ionization enthalpy. Anvita, what is ionization enthalpy meaning? Definition.
So, minimum energy to remove something. Wait, the electron from. I don't remember the word.
Minimum energy required to
From gas.
remove loosely bound electron from gaseous state. This gaseous state word is important. Loosely bound and minimum energy. And this is always positive. You always need energy. That's why this process is always endothermic in nature. Always endothermic. Okay. This is always endothermic. So next, uh, Pratigya, what will happen when we go from the left to right or along the period? What will be the impact in ionization enthalpy?
Increases.
Because we know atomic size will decrease and ionization enthalpy will increase. Logically, it will increase because it's difficult to remove electron. Next, Barinder, shall I mention number of question 8? Barinder, why first ionization enthalpy in 3D series is irregular? Why first ionization enthalpy in 3D series is irregular?
I'm not sure, sir.
Huh. Removal of electron from 4s orbital change the energy of both 4s and 3d, because 4s might have one electron or two electron. We don't know. We don't know what will be the number of electron in the 3d orbital. But we definitely know one thing. The electron removal from 4s change energy in both 4s as well as 3d orbital. And whenever there is a change in energy according to the atom, example, maybe removal of one electron from iron is very easy. Why? Because 3d5 will become full, like half filled stable, very stable. But removal of electron from the manganese will be extremely difficult. Correct? So this pattern is not regular. And also second reason is exchange energy. Chandana, what is this exchange energy?
No, sir, I'm not.
So exchange energy tell us about the symmetry. Ki whenever there is more symmetry, exchange is easier. Correct? Exchange of the electron will be easier because symmetry. Like that's why half filled and full filled are highly stable. Samarth, why ionization enthalpy of 5D element is more than 3D and 4D?
There are poor shielding of F electrons.
Poor shielding of F electron.
Yeah, so they increase nuclear charges attraction on the outer electron, so it's more difficult to remove.
Yes. So why first ionization enthalpy of 5D is more than 3D and 4D? So answer is it is because of the poor screening effect of 4f orbital. And reason shape. That was correct. Poor screening effect of 4f orbital. Correct. And reason due to its shape. Okay. Next, Sarah. Why difference in ionization enthalpy of successive element in D block is less than the representative element? Example, if you see gap between the ionization enthalpy in P block or S block, is it is more, but in D block it is less. Why?
Sir, I don't know.
Different in ionization enthalpy of successive element in D block is less than representative element. So it is because of the counter effect of increase in the nuclear charge and shielding effect in the D block element, because both are increasing. So they are countering each other. Electron will enter into the penultimate shell. Correct? So shielding will be more. But in case of representative element, electron enter into the valence shell. So that is the difference. One is the answer. Counter effect of nuclear charge and shielding effect. One thing, because see, whenever you are talking about ionization enthalpy, it is always related with the atomic size. Small atomic size, more ionization enthalpy. If somebody asks why more ionization enthalpy, simply say smaller size. Just give me a minute. Okay, so one is counter effect of this nuclear charge and screening effect. Second, electron enter in penultimate shell in D block, but in S or P it enter into the valence shell. Electron enter in penultimate cell in D block, but in case of S or P, electron enter in valence shell. Okay. And in case of D block, nuclear charge is increasing, shielding effect is also increasing. So there is not much difference in the ionization enthalpy. Understood, guys?
Yes, sir.
Hmm. How this method of question is going for this chapter, especially this topic? Everybody tell me how is it going? Yeah. Anvita,
Yes, sir.
how is this method of doing question?
Yeah, it's good. So,
Pratigya,
Sir, good.
Varinder,
Yes, sir.
क्या कहना था प्लीज? Chandana,
Yes, sir, it is going good.
Samarth,
Sir, sir, can we do some ordered question also, like exact order of all of them? Because in many questions they give only few elements, not all of them. Then ask which one is the highest and give its magnetic moment and stuff like that.
magnetic moment we are already done with,
No, no,
isn't
no,
it?
sir. Like they'll give four elements,
Hmm.
and then they ask among these which one has the highest or least,
Hmm.
and then its property something else will be there. Like
Yeah,
uh,
yeah.
then we
We
have to.
have this like in ionization enthalpy. There are many questions why this element have high ionization, low ionization electrode potential that we have in our syllabus. Like yet to come.
Okay, sir.
Yeah. So like how is this method for you? Because this is the first time I'm doing in my life. I never did. Sarah.
so good, sir. It's going good.
Okay, so why first ionization enthalpy of zinc, cadmium, and mercury is relatively low? Whose turn was this
Uh,
in Chandana? Yes, Sarah. Who said?
no, sir. I said
Yes,
Mita.
Anvita.
So I
Yeah.
think they fully filled something.
Yes. Because in this case, there is only one reason. Fully filled electron in the subshell. Correct? And in this case, it is highly stable. And when it is highly stable, removal of electron is difficult. That's why ionization enthalpy will be high. Correct? Why? Just imagine if you take zinc, it is 3d10 4s2. S subshell is fully filled, D subshell is fully filled, highly stable, and it is difficult to remove electron from the highly stable element. Next, Samarth. Why second ionization enthalpy in chromium and copper is high?
Sir, first ionization enthalpy will be taken from 4s1.
Uh,
Second one will be from stable D10 configuration.
Yes. So whenever we talk about the ionization enthalpy, always focus on the stability. If any compound is stable, then low ionization enthalpy. If element becomes stable, element becomes stable after removing electron, then you will see that there will be low ionization enthalpy. Why I wrote low here? It will be very, very high. Sorry, high. Understood? So if you have very stable electronic configuration, example case of zinc, cadmium, mercury. So what will happen? Difficult to remove electron. That's why high ionization enthalpy. But if you remove electron, compound becomes stable, then it will be very low ionization enthalpy. Example: if you take chromium, chromium is 3d54s1. If you remove one electron from S, then your chromium 1 positive will become like this. So 3d5 is stable, correct? So first ionization enthalpy will be low in this case. But now this is highly stable, and removal of electron from this stable configuration is very difficult. So if you see chromium 2 positive, which will be 3d4, then we already destroyed half filled orbital. Then this ionization enthalpy will be high. Anybody have doubt? Same thing in copper. Copper is 3d10, 4s1. If you remove one electron, copper 1 positive, then 3d10, it is stable. So first ionization enthalpy will be low. But you have fully filled orbital. Removal of electron in this fully filled orbital is extremely difficult. That's why second ionization enthalpy will be very high. Barinder, but still copper 2 positive is stable element like iron, isn't it? Copper 1 positive, copper 2 positive is very common. How is that possible? According to this situation, we are saying that chromium 2 positive and copper 2 positive are highly unstable because we are removing electron from the stable configuration. But still, copper 2 positive is a popular ion. How is that possible?
Oxidation number.
Uh, Answer is copper 2 positive is stable in aqueous condition, not in the solid state, in aqueous condition because of the hydration enthalpy. And we'll talk about this because of the hydration enthalpy, because it can dissolve in iron. Hydration enthalpy. Reason is hydration enthalpy. Okay. Next, Pratigya. Why third ionization enthalpy in manganese is high? Why
That
third
is the
ionization enthalpy
exception,
in
sir.
manganese is high?
Exception होगा.
Because of the same thing. Because in case of manganese, whenever you want to tell about the ionization enthalpy, what you should know electronic configuration. Without electronic configuration, you can't do anything. Without electronic configuration, you can't do anything. So manganese have this electronic configuration. Removal of two electron, like I am directly writing, a second ionization enthalpy is low. Why? Because manganese 2 positive is stable. 3d5 configuration is stable. But if you remove electron from this stable configuration and try to make manganese 3 positive, third ionization enthalpy, it will be very, very high. Why? You are removing electron from this stable configuration. So this is the thumb rule. If you have stable configuration and you want to remove electron from this, you need very, very high energy. And that's why ionization enthalpy is high. But if you make stable configuration, example here, if you remove second electron, it become half filled, highly stable, then this will be low. Okay. Any doubt? So it's not like we can solve all the question, but at least we can get idea ki which one is stable and why. Okay. Based on that, you can calculate any compound. Got it? Any doubt, guys?
No, sir.
Huh. If there is no doubt, move to the next question. Why zinc show only one oxidation state, that is +2? Maximum oxidation state +2. Whose turn is this? Anvita.
But I don't know.
Reason is same, ionization enthalpy. You know, you can remove two electron from the zinc. Zinc electronic configuration is 3d10 4s2. If you take second ionization enthalpy, it is extremely low. Why? Zinc can easily form two positive ion and convert into 3d10 configuration. So you remove electron from the s subshell. But if you try to remove third electron from the zinc, it is extremely difficult. Why? If you take zinc 3 positive, it will be 3d9 and it is highly unstable. So if you want to make somebody from the stable to unstable, you need very, very, very high energy. It's like if you want to make somebody poor from, like you want to make Ambani poor, and you know what you need to do. Make sense? So, Samarth, can we
सर
say
स्लाइड
कि
अप करेंगे.
hmm, Samarth, what is the use of ionization enthalpy? What are the different things we can predict by using ionization enthalpy?
And its oxidation state,
Yes.
its
In
reactivity as a metal.
so ionization enthalpy uses. If you see uses of the ionization enthalpy, then we
सर
can
हो गया.
use it. Okay. So we predict stability of oxidation state. Example we just did for the zinc. Ki why zinc 2 positive is more stable, not zinc 3 positive? Because ionization enthalpy changes. And Samar, do you remember we were doing one question? There was like 2000, 3000, 5000, directly 32,000.
Yeah, 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 yeah.
Correct?
Yes.
Same. Guys, example, if you are saying for any element, any element, this is, I will change color for this. Example. So question number 16. For any element, you see this situation ki ionization enthalpy, like ionization enthalpy first, second, third, fourth, fifth. Ionization enthalpy 1, 2, 3, 4, 5. And here value of ionization enthalpy is given is like 2500, here 3200, here 6700, here 36,712, and then it will be 40, 100, 860. Chandana, what does it mean?
So the ionization enthalpy is increasing.
Okay, what else?
So due to off field.
See, look at the difference here. Usually, what you will see ki ionization enthalpy is increasing. Okay, so when it come to the ionization enthalpy, usually, not always, usually trend is higher ionization enthalpy value is more. Example, third will have value more than the second, value more than the first. Okay, usually this is the trend. Okay? Every time you increase the, like, ionization enthalpy will increase. But if there is a sudden jump, then you can predict कि removal of fourth electron is extremely difficult. It is increasing usually, but there is a sudden jump. Example here, it's not even double, it's double here. But suddenly, six times. Suddenly, six times means it is too much. What does it mean? This compound cannot lose fourth electron. So probably in this situation, this element belong to group 13. Understood? Anybody have doubt? And we saw recent question in JEE from the same topic, and we have seen in NEET also. It's not like only JEE. Understood? Any doubt, guys? See the sudden change. Example, if somewhere ionization enthalpy is very low, it means compound will be extremely stable. Example, if you see question number 70, why scandium have low third ionization enthalpy? Sarah.
Not sure. So
So this is the scandium electronic configuration. If you take second ionization enthalpy, then it will be scandium 2 positive 3d1. If you remove one more electron, it will be highly stable and become like noble gas configuration. If you see third ionization enthalpy, then scandium 3 positive will become 3d0. It means it look exactly like organ, noble gas. And you know noble gas are extremely stable. Extremely stable. So you will see the third ionization enthalpy is will be low here. Understood?
yes, sir.
Samarth, why K2PtCl6 exists, but K2 nickel chlorine 6 does not exist? Samarth.
With +4 oxidation state.
Hmm.
Um, Sir, in nickel, because of 5D, there is cobalt nickel. 5D, sorry, D8 configuration.
Hmm.
So, sir, up to I think +5 state is more stable than +4 state in nickel.
+5 and +4 state. One more use when we said na stability of the oxidation state. You can also predict stability of compound. You can also predict stability of compound. Whether a compound is stable or not, or does it exist or not. Example, if we see here, we are not bothered about other thing but platinum and nickel.
Anjana,
And you have
come for,
platinum
come for dinner.
and
No, no, no. Like,
Sarah.
come.
Sarah, hello Sarah,
Yes, sir.
your mic was on.
Yeah, sir.
Okay,
I'm
you are
sorry.
talking to someone. It's okay.
No, my roommate, sir.
Hmm. So, if we see platinum, we know in both the situation, platinum is showing +4 oxidation state and nickel is showing +4 oxidation state. According to this, platinum +4 state exists, but nickel in +4 state do not exist. And that's what we want to know. Why? Why nickel do not show +4 oxidation state, but platinum can? That is the meaning. Why nickel can show, sorry, platinum can show +4 oxidation state, but uh, not nickel. So for every element, you should know. Uh, uh, so what is the electronic configuration of this 3D, 4D, 5D? 5D, 5D, 86S2. Is this correct? वाह, हफ्ता बनना है, उस irritating pop-up के साथ और म- Understood? So, if you see here, what will happen in this situation? And in nickel, you have 3D8, 4S2. So, what is special about these two? If you take second ionization enthalpy, second ionization enthalpy will be very high in case of platinum but low in case of nickel. Why? Because in nickel 3D8 is stable. In nickel 3D8 is stable. But if you take fourth ionization enthalpy, because here both are showing +4, we want to tell why. So guys, we want to show ki which one is more stable. Is nickel 4 positive more stable or platinum 4 positive more stable? Logically, when we said this does not exist, the simplest meaning is nickel 4 positive does not exist. So nickel 4 positive is not stable. But platinum can. It means platinum can show plus 4 oxidation state. Correct? So what will happen in platinum? Fourth ionization enthalpy will be low. That's why it can show. But in case of nickel, it will be high. Okay. So removal of the fourth electron from the nickel will be really difficult. But in platinum, it's easy. Who will tell me, Chandana, why? We are saying fourth ionization enthalpy is low in case of platinum and high in case of nickel because question is according to that. But what is your reason?
No, sir, I'm not sure.
So if we see here and you take fifth ionization enthalpy in case of nickel, you remove 5 electron, 2 from S, 3 from D. It will be 3d5 highly stable. But though we need lot of energy to remove 5 electron, which is not practically possible. And that's why you will see nickel usually show only plus 2 oxidation state. It means removal of second electron from 4s is comparatively easier. Make sense, guys? But in case of platinum, as you go down the group, fourth ionization enthalpy means you will see ki 5d6 is stable. Anvita, what could be the reason? 3d6 is unstable. What could be the reason? In D, there is the same thing. But how is this stable?
Because
Lanthanoid
it's not
contraction.
fully filled or half.
Lanthanoid contraction. Lanthanoid contraction.
So what was the question again? Like why is 3D6 unstable, right?
Why? Yes, why 5d6 is more stable compared to 3d6?
I
Because
thought you asked why is like D. Wait, I got confused. Nothing. So understood.
okay, so reason is lanthanoid contraction. Whenever you see unusual phenomena in the lower element, especially 3D, 4D, 5D, in 5D series, it is most of time lanthanoid contraction. If you are confused and see 5D or 6D, just focus on the lanthanoid contraction in 5D, 6D actinoid contraction. Any doubt, guys? But this, when we see ki oxidation state, we focus mostly in case of this solid condition. Barinder, if you have solution state, what are the factors that decide the stability?
Sir, density.
High density more stable. Density is one of the factor, but in the solution state, it depend on standard reduction potential. Samarth, what are the factors that decide standard reduction potential? SRP, standard reduction potential.
The tendency to change oxidation state. Tendency to
Tendency
get
to
reduced.
tendency to get reduced. Correct. How to identify?
Well, like if the oxidized state is less stable than reduced state, then SRP is high.
How to identify this?
The same with ionization enthalpy, like directly to stability of some state.
We will see many factors. It will depend upon example sublimation energy, ionization energy, and hydration energy. It depends upon the sublimation, ionization, and hydration enthalpy. These are the three major factors that decide what will be the overall standard reduction potential. Example, if you have any metal in the solid state and you convert this metal into the gaseous form, which energy will be involved, Pratigya?
Sir, फिर से
Sublimation energy. Energy involved when you convert solid into the gas. Next, Chandana, when you convert this gaseous form into the ionic form in the gaseous state, which energy will be involved here? Ionization energy, because you are making ion. Sara, are you there?
Yes, sir.
Yeah, so if you convert this ion into the aqueous condition in water, then which energy will be involved in this situation?
Hydration energy.
Hydration energy. That's why when you are converting a solid atom into the ultimate uh, ion in aqueous condition, these are the factors that decide what will be your standard reaction potential. Correct? Because most of time in this case, you need energy. So heat is absorbed. Correct? Only in the hydration it is decreased. Example, if you take this from solid to gas, is it endothermic or exothermic, Samarth?
Endothermic.
Endothermic. Always?
So ionization is always. You were asking sublimation, so
Yes. It is
not.
always endothermic because if you have solid, you need some energy to break into the gas. Even if it is the smallest amount can vary, but you always need energy.
Sir, what if it is some
Right.
material which is not solid in room temperature?
So in this case, you this endothermic energy amount is very less.
Okay.
Thermal energy is enough, right? You need low temperature, correct?
Yeah.
So we already discussed this. This is always endothermic, always endothermic. Next, Anvita, what will be this hydration energy, endothermic or exothermic?
Exo.
Exo. And that's why compound is highly stable because when any molecule or atom or ion release energy, it means it becomes stable, correct? Because if it is exothermic, it provides stability. What is the simplest criteria, Pratigya, to become stable? The simplest criteria in full chemistry is energy. More energy, less stable. Less energy, more stable. Now you are releasing energy. So system have less energy, more stable. Any doubt? Okay. So whenever you will say what is the value of electrode potential SRP, then you will always consider this ionization and hydration enthalpy. Sublimation we don't consider in many cases, but ionization energy and hydration enthalpy are the two important criteria. You know, ionization energy is endothermic, so this is positive, and exothermic is negative because it is releasing energy. Imagine if value is negative, then hydration enthalpy is more. Value is positive, ionization enthalpy is more. Make sense, guys? Always thumb rule. If you forget anything, just focus. Key if your electrode potential value is too positive, main reason is ionization enthalpy. If it is negative, only one reason is hydration enthalpy. Okay. Example. What is the question number 19? So if we see from the scandium to zinc, electrode potential value become less negative. I will write electrode potential EP. Electrode potential EP value is less negative. Why? Who will tell? Sandana. Less negative means slightly positive, right? Or positive segment is increasing with the time. If negative value is less, it means positive value is increasing. And we said this electrode potential depend upon the sublimation energy. It depend upon the ionization enthalpy.
Does it have
Be-
anything to do with stability of zinc?
Because example, if ionization enthalpy is very high, compound is highly stable. Correct? If you have lot of sublimation energy means compound is stable in the solid state.
Hmm.
You can't easily convert into the gaseous. If you need a lot of energy to make iron, means compound is stable in the gaseous state, you can't easily make it in the iron. If value is negative, it means you can easily convert your iron from gaseous state to the water. Because it, it is talking about how much energy, and energy is always related with the stability inversely. Understood?
Yes, sir.
Yeah. So these are the three energy that we are talking about. If we are saying value is less negative, means negative portion is decreasing, positive portion is increasing. What could be the reason? What is increasing out of these three? We know only ionization enthalpy. K along the period. Example in 3D series, we know ionization enthalpy will increase. Why? Because atomic size will decrease. And when ionization enthalpy increase, what does it mean? It means your positive part will keep on increasing, negative value keep on decreasing. Now just imagine if we are talking about the electrode potential. When we are saying this electron state, na, I would mention we are talking about which topic? How many topics we are done with? Ionization enthalpy, na? Fifth is electrode potential. But why I didn't write it separately earlier? Because even electrode potential depend upon the ionization enthalpy. Ionization enthalpy is the main factor to decide this. Mostly ionization enthalpy will the major factor to decide this. Tell me, we didn't solve many questions. We are not through with this. But do you think electrode potential is difficult when you know ionization enthalpy? The positive value, ionization enthalpy more. Negative value, hydration enthalpy more. Make sense? Understood, guys? Everybody? Yes or no?
Yes, sir.
Huh.
Yes, sir.
If if you did, then example, if somebody asks why copper have positive electrode potential, what will be your answer, Sarah? Positive electrode potential.
Sir, it can gain electron.
No, no, no. Electron gain enthalpy is different thing. Copper is positive. It means if you can say sum of sublimation energy plus ionization enthalpy will be greater than hydration enthalpy because these two are positive value. Hydration enthalpy is negative. If overall it is positive, it means your ionization enthalpy is more, your sublimation enthalpy is more, and your hydration enthalpy is still low. Make sense, guys? Same like you can correlate size with the shielding effect and nuclear charge. Same here. You positive value, ionization enthalpy more. Negative value, hydration enthalpy more. As simple as that. Let's do one more question. Samarth, why electrode potential of manganese and zinc is more negative than expected? Why, in case of manganese or zinc, it is more negative? Samarth,
So because zinc and manganese can oxidize easily, right? So Zn plus 2 is attainable.
it is more negative because in case of manganese and zinc, your ionization enthalpy is low. Why? Highly stable. Example plus 2 is highly stable. If it is highly stable, then ionization enthalpy will be low. Why? In case of manganese, it is half filled, is highly stable. Example in case of zinc, full filled is highly stable. So if it is highly stable, ionization enthalpy will be low. If ionization enthalpy is low, then it will be more negative because hydration enthalpy overall will be more. Okay, you will see कि even in case of nickel, it is negative. And what is the reason? Here, hydration enthalpy is more. You will be confused in the nickel case because manganese and zinc make sense. कि ionization enthalpy low. Why it is low? Because they are highly stable, full filled and half filled. But nickel is also negative. What is the reason? Hydration enthalpy. And this is given in NCERT. Example, last question of the day. Who will tell? Chandana. Why electrode potential in case of scandium is very low? Low means more negative. Chandana.
Yes, sir.
What could be the reason in case of scandium
Like
electrode
due to
potential is low?
sublimation energy and ionization.
Ionization energy is very, very low. Why? You easily remove third electron and become noble gas configuration. So if ionization energy is low, then you will see it will be more negative because overall hydration is taking upper hand. Sublimation energy plus ionization energy is lesser than the hydration energy. So this is always general rule. More negative, it means hydration is more. More positive, it means ionization enthalpy is more. Tell me guys, is it really confusing?
No, sir.
So in this way you can always correlate. If they are talking about more negative value, it means if it is more negative, what does it mean?